The overall goal of this procedure is to show the suitability of the inline endoscopy technique for drop size measurements in pumping processes. This is achieved using a piped pump setup, composed of a storage vessel, a pump circuit, and the equipment for the inline endoscopy technique. Water is added to the storage vessel to mix with surfactant, after which oil is added via the syringe port and distributed by the pump. Image recognition software is then used to measure drop sizes for an hour. Ultimately, the Sauter mean diameter of the drops is used to estimate the mechanical stress of single-use and standard pumps.
The main advantage of this technique over existing methods, such as FBR sensors, is that the inline endoscopy technique enables reliable and accurate drop size measurements in liquid-liquid dispersions with standard deviations below 10%.
For this protocol, ensure that the storage vessel is equipped with an impeller for the dissolution of the surfactant. The first preparation is to set up the storage vessel. Attach the handwheel valve and the pump loop hose to the storage vessel. The storage vessel must have a syringe port, the pump of interest, a clamp-on flow meter, and a single-use pressure sensor. Then connect the pump head to the motor and prepare the endoscope probe. Next, mount a reflection plane, such as a rhodium mirror, to the probe tip. Adjust the distance between the mirror and lens to 150 microns. Then adjust the screw at 100 microns to focus the objective. Generally, a high-speed CCD camera should already be connected to the endoscope probe SOPAT VF. Next, connect the probe to the stroboscope via a fiber optic cable. Then connect the camera to the computer via an Ethernet cable. Finally, connect the camera to the stroboscope together via a trigger box cable. The next preparation is to ready the software. Open the software SOPAT, which includes an image acquisition and recognition software, as well as a result analyzer. Next, select the image acquisition software SOPAT Cam Control in the main menu. From there, click on the button Direct Device in the upper left corner to detect the camera. Now, under the directory settings, select the location on the computer where the images will be saved and activate the command Create Trigger Subfolders. Then enter the process parameters under the section titled Trigger Mode Ready. Pour 5 liters of deionized water into the storage vessel and switch on the pump to bleed the pump and the pump loop. Then switch off the pump and turn on the impeller. Next, prepare the surfactant Triton X100 and add it with a 10 milliliter pipette under constant stirring. After 10 minutes, the surfactant will be completely dissolved. Now, switch off the impeller and turn on the pump. Position the endoscope probe so that the lens is located directly beneath the inlet tube.
The most critical step is the positioning of the probe. For these investigations, it must be located directly beneath the inlet tube so it does not detect each drop more than once. Furthermore, the probe must be very stable so the images don't get blurry.
Switch on the pump and set the flow rate of 3.4 liters per minute and the pressure drop to 0.03, 0.3, or 0.61 bar by varying the handwheel valve. Meanwhile, weigh out the required amount of the oil directly into a syringe. Then, start the acquisition software SOPAT Cam Control. Screw the syringe on the syringe port and start the test by adding the oil. The running pump distributes the emulsion drops over an experimental time of 1 hour. Before performing another test, the storage vessel and integrated pump loop must be cleaned. To begin the data analysis, open the SOPAT Batcher from the main menu of the software. Under Batch Root Directory, select the location on the computer where the files are saved. Next, load the image series. Select the column Image Series Path and click on Add Image Series Subfolders. In order to specify the drop recognition, load the process parameters provided by SOPAT Ltd. Select the column Search Settings for .pss or offdrag_.mat files. Then click Set Search Settings to load the process parameters. Select the column Search Pattern for .psp or f_star.mat files and click on Set Search Pattern. Now start the image recognition by clicking on the button Start Batch. Next, open the Result Analyzer from the main menu. This tool expresses the drop sizes by various measurements, such as by the Sauter mean diameter. Load the saved files using the command allstar.csv in one folder and click on Load Folders. To view the results, select the relevant value in the drop-down menu, and to calculate the diameters, enter the scaling value of 0.6591 microns per pixel, which is provided by the manufacturer depending on optical setup. Inline endoscopy was used to determine the drop sizes of an emulsion system in various pumps. Compared with other commonly used pumps, a lower mechanical stress is expected in maglev pumps due to their levitated magnetic drive technology. The investigations were performed using a pipe pump setup, which is composed of the storage vessel, the pump circuit, and the equipment for the inline endoscopy technique. The multi-use pumps examined included the Purelev 200 MU and the Purelev 600 MU. Operating conditions were standardized. The Sauter mean diameter of the emulsion droplets was then determined. The Purelev 200 MU pump produced exemplary progression of Sauter mean diameters, as did the peristaltic pump. These Sauter mean diameters were calculated in the last 10 minutes of the hour for over 300 droplets per measurement point, when the droplet diameter reached a steady state. At various pressure drops, a comparison could be made of the Sauter mean diameters calculated with the use of maglev centrifugal pumps and their counterparts. The maglev centrifugal pump series obtained up to 59% larger measured Sauter mean diameters. These results indicated a lower rate of drop breakup and thus lower mechanical stress resulting from the use of the maglev centrifugal pumps, especially for low-pressure situations.
This video facilitates understanding of how to estimate the mechanical stress in pumps using the inline endoscopy technique.